All right, so the next transformation we're going to move on to is this b. So we are done with the a, which was, let me just change that to blue so it stands out, which was y equals a f of x. And now we're moving in the bracket with the x, and we're adding this transformation b. Now the first thing I'll say is that anything in the bracket with the x is going to affect the x. Anything outside the bracket is going to affect the y. The other thing is that there's this weird thing that everything with x is opposite to what it appears. So for example, if we look at those two base graphs that we had in the stretching section, you'll notice that when we put a 2 in the bracket with the x, what do you say about this purple graph? How does it compare to the black graph? And your choices are stretch or shrink. Well, can you see that the x values are shrinking? It's getting compressed towards the x or the y axis. This would be a horizontal shrink. Whereas when you have a 1/2 in the bracket with the x, this green graph has been horizontally stretched. So there's this weird thing that when the b value is greater than 1, the graph is horizontally shrunk. And when the b value is between 0 and 1, the graph is horizontally stretched. Now, just to drive that point home, I'm going to go to a Desmos graph. So we're going to choose something that looks like this. This is the exact same graph we had before. And what we're going to do is I'm going to put in different values for the x. Now, this is going to look a little weird to you, and you know, we won't do ones that are this complicated. But I will say that when the transformation's a, it goes out front of the entire function. Whereas when it's a transformation b, it goes in the bracket with the x. So what I'm going to do first is I'm going to put a 2 in here. So I have to put a 2 in both spots. And what I want you to see is you get this horizontal shrinking, or I like to call it compression, towards the y-axis. If we did that again and we put like a 3 in here, it would be even more compressed. So it's the same shape, and the y values don't change. So you can see that this height is still the same and this min is all the same. The one thing that's changing is that the x values are getting closer and closer to the y-axis. If we did one more, just because we did last time, and I put something like a 4 in here, or let's put a 6 in here even, right? It gets even more compressed. To horizontally stretch, you have to pick a value for b that is between 0 and 1. So for example, if I put something like a 1/2 in here, right? And I would have to do that here as well. Now again, those y values aren't changing. It's going to the same height, but the x values are getting stretched along that x-axis. If I put, again, something like a 1/3, it's going to stretch it even more. Right? And if I went even more and I did a 1/6, right, it would just be even more. Can you see how all of a sudden math becomes just such beautiful art? I feel like if I was an artist, I would want to do like piecewise graphs and transform them. Anyway. Bonus marks if anybody wants to create me a really pretty one. But this is, I can't help myself, this is when you have a b value of a 1/6. So what we want to look at is, why does this happen? Why is it opposite as it appears? And so how can we explain or rationalize in our head that we should always do the opposite? I'll just finish off this part of the note and then we'll talk about that in this table of values below. But what I'll say is that when you are graphing a point y equals f of bx, remember how when we were doing the vertical stretch, we multiplied? We can just say by dividing the x coordinate by b. And that'll do the opposite operation. But let's look at an example. So here we're going to do f of x is equal to 1/2 x cubed. Describe how the graph of the function can be obtained from one of the basic graphs. So you're going to start with which graph? Well, it's our cubic. So we're going to start with y equals x cubed. So let's start with y equals x cubed. Let's draw the y equals x cubed graph. So for our values of x, let's choose -2, -1, 0, 1, 2. And then the y value is just going to be that x value cubed. So we'll get -8, -1, 0, 1, and 8. So at negative 2, we're at negative 8. Negative 1, we're at negative 1. 0, 0, 1, 1, and 2, 8. That's so wobbly. Oh, that was much better. Here, you know what? Let's see if I can do that again. Oh, that was better. Let's go the other way. Awesome. Okay, so we're going to start with y equals x cubed. So that's our first. The second thing we're going to do is think about what this is going to affect. So we know that this is going to affect the x values and not the y values. So let's just look at our table of values. Here, I'll do it in a different color. I think I was doing green on the other one. So now let's look at what would happen. So we've got x, we've got y. So hopefully you're all agreeing with me that this is a transformation on x, right? Because we saw above anything in the bracket with x is a transformation on x, which means our y values are going to stay the same. And the question is, what are we going to do to the x values to keep those y values the same? Well, the equation is y equals 1/2 x all cubed, which means in the equation we're going to half the x before we cube it. Now this is kind of a confusing way to think about it, but I do sometimes find that this can help. So for example, with this one, because the x value is going to be halved, we are going to double it so that we can get the same thing. So instead of having an x value of negative 2, we're going to guess that this is an x value of negative 4. So if I put into my equation negative 4, I've got half of negative 4 is negative 2 cubed, which is negative 8. Ah, it worked. So let's see what happens if we double all the x values. So negative 2, 0, 2, and 4. And will that work? Let's just check like a 2. Let's check a random one. So if I plug in x is 2, I'm going to half it to get 1. And then I'm cubing it to get, oh good, that y value of 1. So when the equation had a b value of 1/2, I had to double all my x values to get the same y value, thereby horizontally stretching my graph by 2. And so what you can write here, so you know how they always have this like start with, and then they want you to know what to do next. We're going to say that we are going to horizontally stretch by multiplying, well, I'm trying to think, let me just see what the textbook writes, because there's so many ways you could write it. You could say by multiplying by 2, but you could also say by dividing them by 1/2, because multiplying by 2 and dividing by 1/2 is the same thing. I just wanted to check the textbook, and it says exactly that. It says horizontally stretch by multiplying x coordinates by 2, and then it says in brackets, or dividing by 1/2. So you kind of get to pick. And really the key thing I'm looking for is that we're starting with this base graph of y equals x cubed, and then it's going to be horizontally stretched. You know, how do we horizontally stretch it? Well, we multiply all the x values by 2, or we divide them all by 1/2, or something along those lines would be great. Okay, so let's just practice that sentence. So for this one, first things first. Oh, never mind. Don't forget to actually graph it. So let's just finish this guy off. So let's graph those points. So negative 4, negative 8. And again, you can see that this has been horizontally stretched by 2. This negative 1 is going to go to negative 2. This 1 is going to go to 2. And this 2 is going to go to 4. So that we end up with this horizontally stretched y equals x cubed graph. Okay, now we can go on. So now we're just going to practice that wording. Okay, so for this one, what are we going to start with? Well, we're going to start with y is equal to the absolute value of x. And then what are we calling this? Is it a stretch or a shrink? Hopefully you're all saying shrink. So it is a horizontally, and then we are going to horizontally shrink by multiplying, actually let's say dividing, the x values, I'm going to give up writing coordinates, x coordinates, 8x values, by 5, or multiplying by a fifth, right? Same thing. All right, give this one a go. Maybe pause the video. This one we are going to start with y equals the square root of x, and then we are going to horizontally stretch by multiplying the x values by 4, or dividing by a quarter, right? Because if you think about this one, this is the same as me saying the square root of a quarter x. So you're either going to multiply by 4 or you're going to divide by a quarter, whatever works for you. So now let's just practice writing functions. So this one says the shape of y equals the absolute value of x, but stretched horizontally by a factor of 8. I still think it's so funny how the textbooks, like, they make you write this long, complicated sentence, and then this is what they write. So the shape of y equals the absolute value of x, but stretched horizontally by a factor of 8. So what is that going to look like? Well, you have to think of it as opposite. If you want to stretch by 8, then it's an eighth that is going to go inside the absolute value signs, right? Because it has to look like you're dividing to make it stretch. It's opposite as it appears. Okay, pause the video and give this one a go. Question is, what are you going to put in the bracket with x? So this time we're going to shrink it by a factor of 2, which means that you're going to actually put a 2 in here. So they also trick you with these ones. Like, they make them both like 8 and 2. And you're like, oh, well, do I put an eighth or do I put 8? Do I put a half or do I put 2? And you have to use the word shrink or stretch to know. So stretch, it's going to look like a fraction, and then shrunk, it's going to not look like a fraction, right? Because this would make you divide by 2. This makes you divide by an eighth or multiply by 8. Awesome. Moving on. So now what we're going to do is get into the actual transformation of points. So I'm going to give you a point like 2, 8, and I'm going to ask you to find the corresponding point on the transformed graph. So for this one, what is this 2 going to make me do? Well, this is going to be a horizontal shrink, which means I'm multiplying by a half or I'm dividing by 2. So I'm going to take that x value and I'm going to divide it by 2 and get a new point, 1, 8. This one, again, I'm starting with the point 2, 8, and I'm going to transform it. What's this one going to be? Well, I'm going to stretch, because it's opposite as it appears. So I'm going to stretch by multiplying by 4 or dividing by a quarter, which I don't expect any of you to ever write. But I'm going to multiply the x value by 4, and I get a point 8, 8. So that we can take a base graph and we can transform it. So just like with the vertical one, you have to look at your key points. Your key points are anytime it changes from like increasing to decreasing. I would actually put a point here too, just to help me out, right? And then here and here. So I'm going to pull off 1, 2, 3, 4, 5, 6 key points. Debatable whether you need that. Well, no, you definitely need that one. Okay, so -4, 0. 1, 2, 3, 4. Yeah. -3, 2. -2, 0. 0, -3. 2, 0. 3, 2. And lastly, 4, 0. Okay. Then what do they want me to do? Well, this is going to be a shrink. So I'm going to take my x coordinates and I'm going to divide them by 2 or multiply them by a half, whatever you want. So I'm going to divide all of my x coordinates by 2. And I always take the time to actually write this out because it prevents me from making dumb mistakes. Okay, so for this one, -4 divided by 2 is -2, 0. Then I've got -1.5, 2. And then I've got -1, 0, 0, -3, 1, 0, 1.5, 2, and lastly 2, 0. Now let's graph it. I should do it. Actually, I can do it in this color because the black graph is my base graph. So what are my points? I've got a point at -2, 0. It's going to erase these other things so it doesn't look confusing. Okay. So I've got a point at negative 2, 0. I've got a point at negative 1.52. And I've got a point at negative 1, 0. Then I've got a point at 0, negative 3. I've got a point at 1, 0, 1.52, and then 2, 0. And then I'm going to connect these dots, and then we're going to talk about this graph a little bit. So all I want you to notice is that it's been horizontally shrunk by a factor of 2, right? Or it's been, all the x values have been multiplied by a factor of, by a half or divided by 2. And so, you know, the couple things I look for is that this little shape here is 2 grid lines long, and now it's only 1, so that's going to help. You know, instead of going out to 4, it's going out to 2, and all those little things. So visually checking that this thing has been shrunk by a factor of 2. All right, pause the video and give this one a go. So it's the same base graph. And this time we are going to be stretching the graph. So we're going to multiply all of the x values by 2. So multiply by 2. I'm going to use a different color this time. Multiply by 2. So my new point will be negative 8, 0, negative 6, 2, negative 4, 0, 0, negative 3, 4, 0, 6, 2, and 8, 0. So let's plot them. Negative 8, 0 would be here. Negative 6, 2. Negative 4, 0. 0, negative 3. 4, 0. 6, 2. Oh, that's not a 4, 0. That's why it's nice when the base graph's there. It just kind of gives you that, like, am I good? And 8, 0. And then we connect our dots. And as long as you draw your dots well, you do your best you can connecting them. So again, you're checking that visually it's been stretched. So again, this thing used to open up to 2 grid lines, and now it's 1, 2, 3, 4. You know, and the whole thing is just looking like it's horizontally stretched along the x-axis. All right, go and practice that.